Oh,
No, sir.
thank you for reminding.
My pleasure, sir. Sir,
Yes.
did you add into the classroom and the messenger group?
Sorry,
Sir, did you add Zahidul
Zohair.
Zuhair Zuhair to
Mm. In
messenger
the
group and the
classroom. Yes,
classroom?
yes, he is there. Here, Hamid Babur, huh? This one.
Yes, sir.
So you write on your copy physical quantities and units. You do not need to take the printout of it. You just have a look on it when you need it. And now, whatever I'm saying you to write, you write. Okay. So this one, you see, the first idea we are getting from here, that is um, related to some daily life experience, or you have some, IQs, depending on your learning from your childhood till now. Depending on that, they are asking you some questions. Just a few years back, they started this type of questions. This is called estimation. What is called
Estimation.
Estimation.
estimation? Okay, so here is the idea. You read here: make reasonable estimates of physical quantities. Uh, this one you write. Make reasonable estimates of physical quantities. Then, for example, what is the kinetic energy of a person running? Like and the common mass of a person, if you think, like, what is the mass of Karim?
Yes, sir.
What is your mass?
Sir, I need to calculate that because it is my weight, not my mass. I need
Just on average, you think what could be now?
the
Just
weight
round
or
up.
the mass.
Yeah, sorry,
The weight or the mass.
mass. I am asking you the mass. Yeah, have you got it? Hello?
Sir, 8.25.
Sorry?
Sir, 8.25.
Yeah, 8.25, not it is your mass. Your mass is 85 kg, right? And if it is
No,
weight,
sir.
then it will be 850 Newton. Is it clear?
Uh,
Hello? So 85 is your mass. Now you think of your normally if you run, then what could be your speed in every second? What how many meters you can go?
uh, Average
Yeah, on average
2 to 3.
three. Okay, let's think of three. Now, what is the formula of kinetic energy?
Kinetic energy, half mv square.
Yeah, so you calculate your kinetic energy then.
360 joule.
Three
360 joule.
360 joules. Very good, very good. So you have here four options, A, B, C, D. Which one is closest to your finding?
293.
That will be the answer. Okay, is it clear?
I didn't get it, sir.
You
Means
got
why
three.
to the.
You got 360, right?
Yes, sir.
So 360 is closest to 293. It will not be
Means
29 joules, 2900. It will not be 29 kilojoules. So it's closest to 293, right?
yes, sir.
That's why we will pick this one because different persons they have different mass, different kinetic energy, different speed, right? So on average, if you think that it's almost 300, right? 300 to 350 or just below 300, very close to it, right?
Yes, sir.
So this is called estimation. Some of the questions are coming in your AS paper one like this. So you write the heading, make reasonable estimates of physical quantities. Then you write also the example. Then we'll go to the next. Do it, huh? Zuhair, are you done with writing?
Yes, sir.
And have you understood the
Almost,
matter?
sir.
Have you calculated your one, your kinetic energy? Zuhair,
Yes, sir.
have you calculated your kinetic energy?
No, sir.
So you can also calculate your one, right? The same way. So are you doing it, Zuhair?
Yes, sir.
So let me know how much it came. So Karim, are you done with writing?
Yes, sir.
Zohair,
Almost.
SI units. We have SI base quantities and their units. What are called base quantities? Can you guess? Hello?
Yes, sir.
What are called base quantities? Why they are called base quantities?
It's like they are the standard form, and we make other quantities using them.
Yes, yes, they are the fundamental, right?
Yes, sir.
Fundamental quantities or foundation quantities, and they cannot be, make more smaller, right?
Yes,
Isn't
sir.
it? Like if you are having the unit of speed that is coming meter per second, right?
Yes, sir.
Isn't it? So meter per second, the unit of speed is the combination or the product or is coming from, it's generated from two other units, meter and second. If you think of acceleration is coming from meter
Meter per
and
second
second.
square.
Meter per second square, though that is also coming from meter and second, these two quantities, two units. Then if you think of Newton, if you break it down, it's coming. Newton is the unit of force, right?
Yes, sir.
So the force formula we know that is F equals ma,
Yes, sir. Kg per meter per second.
kg meter per second square.
Yes, sir. Kg meter per second.
So we have there three units combined or used to get the single unit Newton, right?
Yes, sir.
Isn't it? So that one is not base quantity. Newton is not base quantity. It's the derived quantity. So we like this meter second. We have kg. We have ampere, Kelvin, the unit of temperature, Kelvin. Then amount of substance we have mole. Then and the last one we have luminous index. So these seven are the base quantities, and depending on this, we have other quantities formed. Is it clear? Hello.
Yes, sir.
So you write this list, SI base quantities and their units quickly. Are you done with writing?
Yes, sir.
Just a
Done.
minute, sir.
Sorry?
Done.
Just a minute, sir.
Done. So if you are done, then let me know. We can go to the next. So here we have some examples of derived quantities. Derived quantities are coming from base quantities and derived units are coming from base units. So you write this derived units in terms of base units. So you got your pressure, right? Hello, Zohair.
Yes, sir.
Yes, sir. Yes, sir.
Pressure we are getting from force divided by area. Force unit is Newton and area is meter square. Newton, just today we discussed that Newton, the unit of force, is actually coming from the formula force MA, right? So kg meter per second square. That one we wrote here. We have your meter square. Then we are getting kg per meter per second square. Have you understood this? The numericals, how we got m minus 1. Did you understand it?
Yes, sir.
Karim?
Yes, sir.
Yeah. Using SI base units to check the homogeneity of physical equations. Like we are getting uh, kg per meter per second square, that is coming from force by area, this formula. Sometimes we are also getting the pressure formula for liquid, that one we are getting rho gh, right? Isn't it? Hello.
Yes, sir.
Yes, sir.
So that time, uh, how they are actually matching, that one we understand from the base unit, that is called homogeneity of physical quantity. So you write this heading, homogeneity of physical quantity. That means the other formula you used, P equals F by A, and now you are using P equals rho GH. These two, are they matching or not? Left side and right side, they are coming same or not? To test it, uh, this process is called homogeneity of physical equations testing. Have you got it? Hello?
Yes, sir.
Yeah,
No,
so you
sir.
write
Yes,
this
sir.
heading, homogeneity of physical equations, then you write P equals rho gh, then you write this one already we got, kg per meter per second square. Yeah, Karim,
স্যার আবার একটু বলবেন
sorry?
স্যার আবার একটু বলবেন
Yeah, sure, sure, sure. We got one formula of pressure, that is pressure equals force by area, right?
Yes, sir.
And that one is for the objects, mainly for the objects, solid objects, right? Isn't it?
Yes, sir.
Force by area, that one we get. And this formula is for the pressure of liquid, where we get the density, gravitational field strength, and the height of the liquid. So in previous one, we got kg per meter per second square. That one we are writing here in the left side. And the right side, we are writing density, gravitational field strength, then height, their units we are writing separately. Then we are doing simplification, and we are finally getting the same the one we got before. So the testing of this, that these two equations we are getting, are they matching or not, are they same or not, testing them using the base units. This is called testing of homogeneity of physical quantities or physical equations. Is
Since
it
we are
clear?
proving it.
Have you got it now?
Yes, sir. It's like we are proving it and we are
Yeah, yeah,
sure.
yeah, yeah. Like that. So you write the heading homogeneity of physical equations, then you write this, derivation p equals rho gh. Then you put the values, put the base units values, then you get this relationship. Done?
Sir, 1 minute.
Sir, done.
Yeah, very good. Now we have prefixes and their symbols. Prefixes and their symbols. When we are writing the units, and when we are getting the numerical calculations, uh, like you are getting 1000 meter. So you might get sometimes 100,000 meter. Sometimes you can get 1 million meter. So to write 1 million, how many zeros you are taking? 6, right? Isn't it?
Yes, sir.
So other than writing this 6, we can write 10 to the power 6. Other than writing that 6 zeros, we can write 10 to the power 6 meter. This one is making our presentation more easier, right? Isn't it?
Yes, sir.
Simple, and it's taking very less space to write, taking less time to write. That's why we use power of 10, or it is called index form. It is called also standard form. And apart from this 10 to the power 6, writing 10 to the power 6, we have other way around to write their, to present them in words, like other than writing 10 to the power 6 or 1 million, we can write mega. And even more simpler, we can write capital M for mega. Is it clear? Hello?
Yes, sir.
Yes, sir.
So this one is another way to represent the numbers, uh, to get them in a single letter, 10 to the power 6 or 1 million, or after 1 there are 6 zeros. A very simple way to write. Similar to that, we have giga, we have tera. Tera means 10 to the power 12, giga means 10 to the power 9, and other things kilo centi milli milli means 10 to the power minus 3. Centi means 10 to the power minus 2. Then we have micro, 10 to the power minus, we have nano, 10 to the minus 9, pico, 10 to the minus 12. So in our applications and knowledge of ASA2, we have this writings or use of these symbols, prefixes. That's why we should learn them, and we will apply also in some of the questions. We'll get it. So write them, huh? Prefixes and their symbols. Are you done with writing?
Yes, sir.
Yes, sir.
Okay, very good. Then we have uh, previously we had this scalar and vector. Uh, you see, let's go through the learning outcomes again. How much is done? So we did this. Make reasonable estimates. This one we are done. Understand that all physical quantities consist of a numerical magnitude and unit. This one you know. And we did this. Base units, derived units. We did use SI base units to check the homogeneity of physical equations. We did this. Then recall and use the following prefixes. We did this. From pico till tera, we are done. Now we have 1.3 errors and uncertainties. Previously it was in topic 2. That's why when we prepared it, we followed this. In our previous syllabus, scalars and vectors, it was in topic 1. That's why here it is with the previous notes. Already you got. It is a continuation. So you write it now, scalars and vectors. The other part we will do later. Okay, the uncertainties and other things related to uh, topic 2 previous time, that one we'll do later. First we do scalars and vectors. So scalar and vector, you have the idea, right? What is called scalar?
Which doesn't have a magnitude.
uh,
Wait, direction,
it does not have any direction.
direction,
It
but has a
has
magnitude.
magnitude means a numerical value, right?
Yes, sir.
Yeah, so everything has some magnitude, but it can have direction or it does not have the direction. So vector, they have both magnitude and direction. And you know the examples of scalar quantities, right? Here we have
Yes,
some:
sir.
distance, time, temperature, speed, density, etc. Then vector quantities also we have some uh, quantities examples. So please write it, huh? This way you write so that we can go quickly. Scalars have only magnitude, no directions. You write the heading scalars and vectors. Then we start, huh? Scalars and vectors. Scalars have only magnitude, no direction. Vectors have both magnitude and direction, and their examples are there. So write quickly, huh? Are you done with writing? Hello?
Yes, sir.
Sir, 1 minute, moment, please.
Yeah, please finish, huh?
Sir, could you please erase that line?
Sorry?
Sir, the red line.
Yeah, remove.